Yes, mysterious ways. There we go. We're moving mysterious ways. We're going to graph basic logs now, folks. Hold on to your horses. Alright, so we are going to do 3 log graphs on the same one on this page here. We're going to start off with the basic, just log of x, LBR f of x, 10 teams. So log base 10. So that's where the 10 team comes from. 2 teams, log base 2. 5 teams with log base 5. I've already filled in the tables for you, so we have various points, the x values, and what they're equal to. And we're just basically going from real small numbers, close to 0, all the way up to 16 in each case, and hitting some decent points, some not so decent points. So that's what we're going from. That's our domain from 0 to 16. So let's start plotting the points. So I'm going to start in the middle of my table, and at 1, over 1, I'm up 0. So I put a point here. Hold on, I got to put a change right to the points right there. So put a point right there, and then I go 2 is up a third, so it's probably a third of the way up, and 4 is about 2/3 of the way up at 0.6, and let's see here, 8 is almost up to 1, it's at 0.9. And finally, we get 1.2 for 16. So a little over 1 on the height. Going the opposite way, at a half, it's down about a third. At a quarter, it's down to 0.6. Then about 0.9 as I get even closer, like an eighth, etc. So if you take a look at this thing's going to start hugging the wall right here. It doesn't actually go over. Oops, it changed colors on me. And if I connect the dots, there's my f of x. Okay, and so that's your basic log of x. Alright, I'm going to do the same with the other 2. You give them a try as well and see what happens. And then come on back. So actually, here's log base 2. If you notice, nicer points. 1, 0, same point. Then it goes up to 2, 3, and 4. So this is our g of x with log base 2 of 2. And going the other way, our nice points actually fairly decent coming down. Same thing, does not hug the 0 as close or as quick. Now I'm going to do the same with h of x. So h of x, which is the log base 5 of x, does a similar thing. It comes in between. Okay, same thing. Approaches quicker to 0, rises a little higher than f of x quicker, but not as quickly as g of x. Okay, so that's completing the graph, and you guys should be able to plot points and do that. So now we're going to answer a few questions that go along with these. Okay, so the first one says, what does the graph indicate about your domain of your function? Well, did it ever quite reach 0? And the answer is no. So it's bigger than 0. And because we are limited, we actually, on the function itself, we only went up and plotted up to 16. So if you want to be technical, we only went from 0 to 16 we looked at. But as you can see, it keeps going on forever, all the way up to infinity. It would take a long time to get there because it doesn't rise quickly, but it is still going towards infinity. Some of you guys might write that. You could state an answer that's just x has to be greater than 0. That would be true. If you remember your old interval notation back from 9th grade, open parentheses because it doesn't hit 0. We don't do a bracket, and it goes to infinity, and infinity's always got parentheses because you could never reach them. And some of you guys might say, hey, it's got to be positive and real. So those are all valid answers on describing the domain of the log of all 3, actually. The log of x, the log base 2 of x, and the log base 5 of x, okay? Describe the x-intercepts. Well, what happened there? Hopefully you noticed they all hit at what point? 1, 0. So all 3, the f of x, g of x, and h of x, all in this case hit right at 1, 0. It's the only spot across the x-axis. Describe the y-intercepts. What do you take a look at? Well, I hope you say it doesn't exist. No y-intercepts. It comes close. It's hugging that y-axis, but it never hits the y-axis, so no y-intercepts would be a proper answer on that. Alright, for question D, it says find the coordinates on the point on the graph with a y value of 1. What is the height of 1? Well, you got to go over for the 10. If you take a look at it, you go all the way over to 2, or to 10, and that would go up 1. You're going to approximate because you don't have an exact 1. We can clearly see under the 2 log base 2 of x that it hits up 1 at 2. That's right in the table. And at 5, it is approximately, once again, is 1. All that stuff comes down to, though, is if I did log, remember, log base 10 of 10, if I did log of base 10 of 10, we do the change of base formula. Remember, it would be the log of 10 over the log of 10, which actually is 1 over 1, or they cancel out, and it's 1. So either way, the same number value. So that's why at 10, it's up 1 because that log base 10 of 10. Log base 2 is going to be a 2 of 2 is going to be 1, and 5 of 5. Okay. Finally, describe your behavior in the pattern of function as x is approaching 0. So as our x approaches 0, what happens? Well, if you remember the graph on the page before, as it got closer to 0, it's going down here, right? So x is approaching negative infinity. Okay, we're going to talk more about all those pieces in this chapter. Alright, answering these other questions. What's going on as the end of behavior of x goes towards infinity? So as we go to the right on our graph, what's happened? Of course, the y is going towards infinity. It's going up and up and up forever, even though it's only a slight increase, slightly. Slight at a time. Slight increase, but it is going towards infinity. We went out far enough, that's what we're going towards. Describe the range of this function. How high to how low? Well, hopefully you notice that if it goes from, when it's close to 0, it's down at negative infinity. So x has got to be bigger than negative infinity. Sorry, actually the range, so its y is bigger than infinity. And it goes as high as positive infinity. You guys might also say, hey, it goes from negative infinity to positive infinity. Or you might say the set of all reals, if you remember that. Coming back from 9th grade, okay? And does this thing have any maximums or minimums? What do you say? Well, I hope you look at the graph and you say none. Okay? There are no peaks or valleys, okay? It just keeps going. The one going down forever, the one going up forever. Yes, it had a curve, but at no point did it turn. So no peaks or valleys. So there are no max or mins in this case. All right, our summary is as follows. Okay, so we already talked about it. The domains of the function for f of x, g of x, and h of x all start at 0, not including, and go up towards infinity. The range starts down at negative infinity, down way down below, comes up, curves, and slowly goes up forever towards positive infinity. Same for all three. We said all three had x-intercepts of 1, and none of them had a y-intercept because it never hits the y-axis. Where was the point value at 1? And we described why that was 10, 1, 2, 1, and 5, 1, depending on whether it was that 5, the 2, or the 10 on the base. The behavior x as it goes towards infinity, okay? As it goes towards 0, they're all going towards negative infinity. And as it goes to the right towards infinity, they all go up towards infinity. So that's your summary chart of the whole bunch of questions we just answered. All right, that's it for now. I just wanted a brief introduction. We're going to do the others in class and graph them together. If you want to try to go ahead of time and do pencil and stuff like that and see if what you can do, be my guest. Otherwise, we'll see you in class.